I restored this 5150 many years ago, but I ended up never really finishing the project, mostly because I was missing some parts. So today we're going to do some upgrades to make it perfect and finalize this project. We're also going to repair a graphics card that should be the perfect match for this machine. As things turned out in this video, I ended up repairing 2 cards and troubleshooting a RAM issue too. The plan for this build is basically to make it into a perfect Hercules machine. I don't think there is tons of games that support Hercules, but there are a few. If the case is stuck on a 5150, just lift it gently at the back. It's most likely stuck in the power supply back here. We have already replaced the smelly little refills in the power supply. I have also aligned the heads on the floppy drive. This machine was incredibly noisy, so I have replaced the fan with notcher to make it much more enjoyable to use. I have also replaced all the tantalum caps on the motherboard. So if you came for the magic smoke, you're gonna be disappointed. We have replaced the original CPU with the V20 and installed a skinny sprint in the previous video. So this machine is now running at 7.36 MHz. This IBM was made in 1982, so it has the early 16 to 64K board. It has been maxed out to 64K. I have also installed additional 256K with an original IBM RAM card. This card was installed in this IBM when I bought it years ago, but I think it only had these ceramic gold top chips installed. I later filled up 2 more banks. But this machine obviously needs 640K, so we're going to upgrade some more. This IBM already has Hercules graphics, but this is a clone branded DDTT. It has served me really well for many years. But I actually have an original Hercules card for this project. However, I think this card is actually broken. So let's start by fixing it. The IBM is freshly tested, so we can go ahead and test the Hercules card. How about I connect power? The IBM is freshly tested, so we can go ahead and test that Hercules card. Okay, we've got some beeps, and we've got random characters on the display. So I was correct. This looks to be a faulty card, but we do have a cursor, so I'm gonna wait here and skip ahead and see if it posts. Okay, it's reading from the floppy, and it boots. So the system seems to be working perfectly fine, but it does add a bunch of random characters all over the display. This looks pretty typical for faulty RAM chips on the graphics card. So place your bets, and I guess we'll find out. The RAM on this Hercules card consists of these MT branded 4264 chips. These are 64K by 1, and there are 8 of these, giving us a total of 64K. My DDTT card doesn't have that RAM installed on the card. Instead, this card is using 2 KM41464A chips. And these are 64K by 4. So I went through my stuff and found another clone. This is a Hercules card too. It's a Tamarack TD3088A, and conveniently it has all the chips installed in sockets. This card is missing a few chips in these sockets here, but I tested this card and it's perfectly working. So these must be for some extra features. Probably the parallel port. Well, I've had many MT branded RAM chips go bad in Commodore 64s, but I never had any issues with MT branded chips this old. So I think those quality issues they had came later. I'll start by adding some fresh solder to all the pins while the board heats up. If you don't have a preheater, just use a cheap heat gun from your local hardware store and heat the board up for a few seconds before you start desoldering stuff. It's going to make the job easier and more enjoyable. We could replace one chip at a time and test the card in between. But if one of the chips has gone bad, it's a matter of time before the next chip goes bad. So I'm going to at least put them all in sockets. And I just remembered the BIOS on this early board actually can't take 640k of RAM. So we're also going to build up some custom PCBs today to make an upgrade possible. Okay, so this is going really well, so I'm going to desolder all the chips and skip ahead here. Okay, that went without any issues. So next I'm going to check with the desoldering needle if all the pins are loose. So these are just stainless hollow needles, and they are designed to push old solder out from stubborn through holes. But they are also great to check if the pins are loose. Since they are hollow, they go on top of the pin, and then they go down the through hole, and you will notice immediately if the pin is stuck. This works a lot better than pushing on the pins with a screwdriver. So I highly recommend getting one of these. You can find this on all the usual places online. Quite often the chip will just fall out while you're checking if the pins are loose. But apparently not this one. So that must mean it's stuck to the pads on the other side of the board. So I'm going to add some heat with the Rework station. Okay, I think it's coming off now. Yep. Now it dropped. And here's our first chip. So I'll just do the same process until all the chips are off the board. Okay, I think that went well. And sure enough, there was some old solder still left on the other side of the board. So if I had pulled on those chips, without checking every single pin and using the Rework station, some of the pads would have lifted. So next I'm going to let this card cool down very slowly before we continue and install sockets. Okay, let's clean this up and check all the pads. Yeah, this is looking good. I'm going to wash the board after I have finished this video. Otherwise I'm going to have to wait until tomorrow for the board to dry before we can use it. But this is clean enough for now. So how about this side of the board? Yeah, this is looking good. And all the through holes are clean from solder. Perfect. So minding the notch. We can install all the sockets now. If the board gives you any trouble, I like to use this pointy desoldering needle. If there is a tiny amount of solder left in the through hole that is preventing me to install the socket, it gets pushed aside and the socket can then be installed. I like to solder just 2 of the pins first and then check if the socket is aligned and sits flush to the board before I solder the rest of the pins. Not important, of course, but I like stuff to look neat. Okay, and it's done. I was a bit lazy and used thick solder, but this is going to be good enough. So let's clean that flux up. Okay, that's clean enough for now, and the rest will come off in the wash. And instead of those empty RAM chips, we now have sockets. I'm going to borrow the chips from this clone card, and then I'll order some more. And these guys are TMS 4164. They are actually slightly slower than the original chips on Hercules card. But if they work on this card, they probably work on the original card too. I'm going to start by testing the card with all the chips replaced. And if my guess was right, I'm going to find out exactly which chip was bad. Okay, Hercules card installed. All bets are off. Fingers crossed. We've got some beeps. We've got a cursor. No random characters on the display yet. By the way, when the 5150 does the RAM count, it doesn't show it on the display. You're just gonna get a flashing cursor. And enough time to go and grab some coffee before it's done. Okay, it's seeking the floppy. Oh no! It didn't fix the issue. Well, it sort of did. But we've got a bunch of zeros now. So all the random stuff is gone. Oh, I think there is an error, but it has been overwritten by time and date. I think it says something about substatus something, but then it has overwritten the rest with a date. And then a bunch of zeros here, of course. So, what the heck is this? I was expecting this to be a quick repair. Yeah, we're getting more zeros here. Oh, crap. Yeah, it adds a couple of zeros on every line. So that card is not fixed. Let's list a directory. Yeah, that is really messed up. So it's not just adding a bunch of zeros. Some of the characters are wrong too. Let me move in closer. Yeah, as you can see, it has replaced some of the characters with the wrong character. Quite a few actually. So instead of whatever number should be here, it uses a dash. And so on. So this kind of looks like a character ROM issue. But the character ROM was working before I replaced the RAM. So why is it behaving like this now? Well, since the card behaves like it has a new fault, it only makes sense to test it again with the original chips. But before we can install these guys in the sockets, we need to remove the old solder left on the pins. Otherwise these chips are going to destroy the sockets. So I'll clean these guys up and we can do a test. Wow, that was boring. I hate cleaning up chips. But these are probably not made anymore, so I guess they should be saved, whether we need them today or not. So let's reinstall them in a Hercules card and find out if this card now has a second fault. Okay, card reinstalled with the original empty RAM chips. Let's see how it behaves. Okay, all the random characters are back again, so we definitely have a faulty empty RAM chip. Possibly more than one. We've got a flashing cursor. It's reading the disk. And it boots. But we don't have all those zeros that we got with the replacement RAM chips. So that must mean that one of the replacement chips is bad too. But why didn't that fault show up when I tested that clone card? I guess that's the next thing to test. So I'll put these RAM chips back where I found them, in this Hercules clone. Okay, the Hercules clone card installed in the machine. Let's see how it behaves. It worked perfectly just a couple of hours ago. Well, we've got a cursor and no added zeros so far. Okay, it boots from the floppy. Oh, look at this. And now it introduced a bunch of dots here. So, and yeah, a couple of the characters here are wrong. So, we have faulty RAM chips on the spare clone card too. Well, at least we didn't introduce any fault on the original card. So I guess that's a good thing. Yeah, that is pretty messed up. Let's list the directory. Yeah, this is definitely messed up. But it's not quite as bad. Well, actually it is. This is just completely unreadable. It has replaced pretty much every single character in the file name. But funny enough, most of the numbers are still correct. And then we have these added dots here. So definitely a bad chip. I went through the tedious task of swapping out RAM chips more or less randomly until I found 8 working chips. And then I just replaced one of them until I had identified the bad chips. One of the TI chips and no less than 4 of the empty branded chips were bad. So apparently these empty branded chips here were affected by the quality issues that Micron had in the 80s. And as you can see, the clone card is now working perfectly. I realized I should probably check if I had any spare. And apparently I do. I don't remember what project I ordered these for, but let's snatch them. Even though half of the chips are still working from this card, there is no point in reinstalling them. They are obviously going to go bad within months, weeks, or perhaps days. These are TI branded chips too. The original chips on this card were 150 nanoseconds, and these replacement chips are 200 nanoseconds. But so were the chips in the clone card, so this is probably gonna work okay. I think these chips are tested, because I have marked them with the small green dots, but I don't remember why. Okay, fingers crossed. We've got a flashing cursor. It seeks. And it boots. And no additional characters yet. Yep, that totally fixed it. Awesome. So we had to fix 2 Hercules cards instead of 1. So this machine finally has an original Hercules card installed. Okay, no time to rest. Let's press on. Fixing up those graphics cards took a lot longer than I expected. Probably because I'm an optimist. And here's our next issue. So this is an early board with an early BIOS. And apparently IBM wasn't expecting us to use 640K in these boards, because this early BIOS can't handle that much RAM. To fix this issue, we need to download and burn the latest BIOS for these machines from -0 degrees, and then use an EPROM adapter. Now there are plenty of projects to build one of these up. However, there is a problem. So if I install the floppy drive, check this out. With all the Gerber files I could find online to build adapters, all the pins on one side are being shorted by the floppy drive. So the commonly found adapters online won't work in the 5150. So that brings us to the sponsor of this video, PCB. To solve this issue, I jumped into KiCad and designed new boards specifically to fit in the 5150. If these work, I will leave a link in the description below to where you can download the Gerber files for these and order a set if you need it. I'm gonna move in real close here to show you these, because I have sort of put the instructions in the silk screen. So you can use these with 4 different EPROMs: 2764, 27128, 256 and 512. And you need to add 3 resistors here. And depending on what EPROM you use, there's sort of like a matrix here. So for instance, if you use a 27256, you need to add a 10K resistor on these pads, 10K resistor on these pads too, and a 0 ohm resistor on these pads. So this way you don't need any instructions. You can just look at this matrix here and immediately see what needs to be done. And for instance, if you're using a 2764, you just add 0 ohm resistors on all 3 pads. If you don't have any 0 ohm resistors, you can just bridge these pads, or just use a tiny piece of wire. And if you're using a 27C512, then you need to add 10K resistors on all 3 pads. I hope this makes sense, but I thought I'd make it as easy as possible to build these up. And aside from those resistors, the only thing you need is some pin headers and a socket. When building these, you need to add the resistors first. I'm gonna go with a 27256. So I need to add 10K resistors on these 2 pads and a 0 ohm resistor on the last pad. So we've got plenty of these tiny resistors. Well, that was a bit too much flux. Apparently a bit too much solder too. But no one will ever know. And then we need 1 0 ohm resistor. Wow, that resistor is completely drowning in flux. Let's add some solder. And this board is now configured for a 27C256. I'll clean the flux up right away, because it will be hard to reach later. Next we need to install the 2 pin headers that are going to go into the socket on the motherboard, and place the PCB on top. You have to install the pin headers before the socket, otherwise it won't work. I'm gonna be a bit stingy with the solder on this row, because I made them as small as possible. That means the socket is going to sit very close to this row of pins. So no room for big blobs. At least not on this row. I guess that depends on what type of socket you have. But the sockets I use sit quite close to the board. And the final part to go in is the socket for the EPROM. Yeah, that is a tight fit. At least with the sockets I have. Yeah, that's a snug fit. So don't use too much solder on these pin headers. So all we need to do now is to solder the sockets. This adapter should be done. I hope it works. Well, there's actually one more thing you need to do after you have downloaded the bin file, before you can burn it. Because the original BIOS is only 8K, but these EPROMs are much larger. So if you just burn the 8K file, it will sort of sit at the bottom of the EPROM. That's a bit of a lame explanation, but that's sort of how it works. So you need to keep doubling that file until it reaches the spot on the EPROM where it's accessible by the IBM. And that is easily done by using this command here. So every time you run this command, it will double the size of the file. And depending on what EPROM you use, you may need to do this a couple of times. And then you need to use an XG Pro or something similar to program the EPROM. And it should be ready to use. And here's what the final contraption looks like. I tried to make it as small as possible. Let's go ahead and install it on the motherboard, with the notch facing in the same direction as the original ROM. And not to the important bits. Let's install that floppy drive. Yeah, that looks good. There is plenty of space between the floppy drive and the pins on the EPROM. So looking pretty good so far. Okay, let's see if it works. Fingers crossed. Okay, I think we had high voltage and a flashing cursor. It reads the floppy. So it is at least executing code. And it boots. Awesome. Success. So there you have it. This 5150 is now running the latest BIOS that was available for these machines. By the way, I was able to find one web page that was selling something similar, but I couldn't find any open source projects. And these of course are. So go ahead and download the files. Okay, armed with the latest BIOS, we can now install some more RAM. This is an AST 6-pack Plus, a very popular upgrade on these machines back in the day. This board also came with a parallel port, but since the Hercules card has a parallel port, I'm going to skip it and save one slot. This card also has a serial port. That means we can skip the serial card that came with this machine and save yet another slot. This is important because these machines only have 5 slots. The spot where the revision number should be is blank. So I don't know which revision this is, and if you're an expert, please let me know. So except for those 2 ports that I just mentioned, it also has a real-time clock and up to 384K of RAM and pin headers for a game port. Now that could be useful, so I'll see if I can find or build a matching cable. And I think I managed to disable the parallel port here by disconnecting the jumper in the middle here. And the next issue is that I don't know if it plays well with other expansion cards. So at the moment I actually don't know if we can use this card to go all the way up to 640K, since the motherboard only has 64K. This card, by the way, is completely untested, and in this first test I have set the switches to 64K of RAM on the motherboard and 384K of additional RAM on this card. So for this first test I'm gonna go without the IBM expansion card installed. This is a pretty heavy card, so quite flimsy. This IBM came with 2 guide rails for full-length cards. We can move these, but instead let's just move this card to slots where we already have a guide rail, and I'm using the second rail for the Hercules card. Okay, let's see if that card works, and if I manage to set all those switches correctly. We've got a cursor and the IBM boots. I just realized I completely forgot to check the switch settings on the motherboard. But let's run check it anyways. And go to installed hardware. And it's recognizing 319K. So that is incorrect. And that is because we need to change the jumpers on the motherboard. Something extremely annoying just happened here. With the AST card installed, the speaker is now making an extremely annoying noise. It seems to be picking up interference from the AST card. I guess we could try to move it and see if it helps. To change the BIOS settings on a 5150, you have to toggle switches on the motherboard. And switch 2, unfortunately, sits right under the skinny sprint. So we need to remove it. And here is switch block 2. Upgrading the BIOS also affects how you change the switches. So pay attention when you set these settings. And for a total of 448K, we need to set the switches to 11001. I'm just going to install an 8284 in the socket for now, because we're going to change that switch again. And later we will reinstall the skinny sprint. And back in check it, we now have 447K. Well, that's close enough. But why not 448? I moved the 6-pack Plus away from the speaker back here, but it still makes that incredibly annoying high-pitched noise. So this could be a problem. Okay, let's find out next if the AST 6-pack Plus will play nicely with the IBM RAM expansion card. I know we can stack several of these in the 5150, but I don't know if the 6-pack Plus will play nicely with the IBM card. I changed the jumpers on the motherboard to a total of 640K of RAM. We've got 64K of RAM on the motherboard and 256 on this card. That gives us 320. So I changed the jumpers accordingly on the 6-pack Plus. Fingers crossed. No nasty error beeps. We've got a cursor and it boots without any errors. Now let's jump in to check it and see if it likes the combination of the two cards. Yes! 639K. So it seems to have dropped 1K somewhere, but that's close enough for me. Okay, so apparently you can combine the original IBM card with an AST 6-pack Plus. The IBM card only has 256K, so it's not enough with two of these cards to reach 640K on the early motherboard. So that's a winner too. Well, playing games without sound is no fun. So the obvious choice for the last slots is of course a sound card. The PC speaker stopped making that annoying noise. Not sure what that was all about. So this game has a Hercules mode. Let's go with ad-lib sound. And apparently the sound is turned down. Yeah, it totally works. And it's actually quite smooth, even at the original speed. Since I removed the skinny sprint, we're now running at the original 4.77 MHz. So I'm gonna call this a win too. Okay, now I actually have a very noisy XT on the bench, because I had to do a sanity check here. One of the games I want to try out in Hercules mode is Prince of Persia. So I made a copy of version 1.1, but it just kept asking for floppy 1. Then I tried version 1.2, but ran into the same issue. And then I tried version 1.3, and it finally asked for disk 2 instead of disk 1. But then it just hanged. But as you can see, it's actually working. So that's why we have the XT on the bench. Because I wanted to try these floppies, and as you can see, they're working just fine. So, unfortunately, there is some weird compatibility issue. Very strange bug. Now, let's get back to the 5150 and install a fresh coin cell. Wow, what an incredible difference. That Noctua fan is so much nicer. Oh, I think we just got a clue from the 5150 here to what might be wrong. We quickly had a 4010 201 error and parity check 2. Okay, so maybe that's why Prince of Persia wouldn't run. I removed the AST card and changed the switches accordingly. But we still have the error. So it's not a bad chip on the AST card. Okay, IBM card removed too. And I changed the switches to 64K on the motherboard. And the error is gone. Okay, so we have a bad chip on the IBM card. Okay, this is a little bit embarrassing, maybe. The chips in this bank here have small red dots on them. And that means I have used them to troubleshoot some system. But I don't remember which one. So I removed them from the board and changed the settings. So this card now has 192K. Now let's try again with an IBM card only. So 192 plus 64 is 256. I changed the switches on the motherboard to 256K of RAM. Let's try again. And the error is gone. So apparently one of these guys is faulty. But that's okay, because we actually have more than 640K in the machine. So we don't actually need them. I changed the switches on the AST card to start at 256K instead. And the switches on the motherboard back to 640K. Okay, let's try again. Okay, and still no error. Let's run check it. And we have 639K. I wonder where that missing K is. It's kind of weird. So let's try Prince of Persia version 1.3 again. This is the floppy version. So we're asked for disk 2 now. Oh, it works now! Awesome! Wow, so that marginal chip was causing Prince of Persia not to work on this machine. But luckily that chip failed completely. Otherwise I wouldn't have known what to look for. So that was really lucky. Okay, perfect. So this is one of the games I want to try out on this machine. With all its glorious Hercules graphics. By the looks of it, this game was designed for CGA. Then probably ported to Hercules graphics. Because with the Hercules card, the graphics are a bit compressed. And they don't look quite right. Well, this game runs pretty smooth on an XT in CGA mode with the skinny sprint installed. It is definitely playable at original speed, but it's a bit sluggish. So let's remove that 8284 and install the skinny sprint again. I'm gonna leave the sprint at 7.36 MHz because that seems to be the speed limit of the floppy drive. We can go faster, but then we would need to install a turbo switch. And that's an easy thing to do, but I don't have any slots left. So I'm just gonna leave it like this and play faster games on the XT instead. I think 7.36 should be plenty enough for this machine. Okay, let's try Prince of Persia again at 7.36 MHz instead of the original 4.77. Well, it's actually still slightly sluggish. Well, just to check if my notes are correct. Oh, they're not. So this machine is actually running at 4.77 MHz. I must have the wrong crystal on that skinny sprint. Oh, that's interesting. When it's doing the video speed tests, I got that weird sound from the speaker again. And sure enough, the benchmarks are showing regular V20 scores at 4.77 MHz. So something isn't quite right with the skinny sprint here. Oh, I found an issue here. This sprint is missing the turbo jumper here. I must have used this machine with a turbo switch. Removed it and forgot to install the jumper instead. So with this jumper, the sprint is now set to constant turbo mode. I will put some links below to the Gerber files if you want to build one of these up. If you need building instructions, just search for Skinny Sprint on this channel and you will find some videos about this project. Okay, we're back in Check-It, and this machine is now running at 7.37 MHz. So we're getting a significant speed increase from the original 4.77. So how about Prince of Persia at this speed? Here goes. Yeah, that is quite a bit faster. Yeah, the skinny sprint is making this game a lot more enjoyable. There is no lag whatsoever. But I also noticed something here. This pin actually introduces some tiny artifacts in the black area of the screen. So if you're ordering parts for a skinny sprint, I would probably go for 7 MHz to see if those artifacts disappear. And at 7 MHz it's probably going to be fast enough for pretty much any game you want to play on the original PC. It's barely visible, so I'm not going to bother, but it is worth considering if you're ordering components for your skinny sprint. But I can't think of anything else to add. I'd say this is the perfect Hercules machine now. Let me know if you can think of anything else to add to this project. If you found this video interesting, consider watching this video next. If you have already watched it, hit the bell icon below and set it to all, to get a notification from YouTube when the next video is out. I will end this video by saying thank you to my patrons. I appreciate your support. If you want to support me too, consider becoming a patron. Patrons get ad-free early access. If you like this video, let me know with a thumbs up in the comments. If you're a regular viewer, consider subscribing to this channel. Thank you for watching, I'll see you next week.